In this video, I'm going to look at some ratio type questions that might appear in a GCSE paper. These are more, for want of a better phrase, obvious type questions where we see the ratio explicitly. This isn't a definitive list of questions, but hopefully it will give you some idea of the kinds of questions that may appear in an exam paper. In each case, pause the video and have a go at the question yourself. The first two questions I'm going to focus on deal specifically with equivalent ratios through simplifying. So you might see a question looking something like this. This kind of question more than likely will appear in a non-calculator paper as the numbers involved are not considered to be too demanding. So pause the video and have a go and press play when you are ready. For part A, there's only one mark. It's a simple case of knowing the multiplication tables. We are going to simplify this ratio as you would with fractions. To simplify this, we need to divide both sides of the ratio by the same amount. What number goes into both 8 and 36? And of course the answer to that is 4. 8 divided by 4 is equal to 2, and 36 divided by 4 is equal to 9. For part B, notice that there are 2 marks. This would suggest that there are going to be 2 stages to this problem. If we look at the ratio, we can see that on the left-hand side we have 5 kilometres and on the right-hand side we have 200 metres. The units of distance are different. We have kilometres and metres. We therefore need to make both units the same. For me, the simplest way to do this is to turn the kilometres into metres. There are 1,000 metres in a kilometre, so 5 kilometres is equal to 5,000 metres. So we now have a new ratio of 5,000 metres to 200 metres. We now simplify. We can divide through by 100. These noughts cancel out, so to speak. We are left with 50 to 2. And of course, 2 goes into both 50 and 2, so we now divide through by 2 and we are left with 25 metres to 1 metre. So that would be 1 mark for converting the units from kilometres to metres. You could, of course, converted the 200 metres into kilometres. And you get 1 mark for simplifying the ratio. Here's another simplification type question. Circle the ratio that is equivalent to 4 to 10. Pause the video and have a go. Again, to simplify this ratio, we have to divide the left-hand side and the right-hand side of the ratio by the same amount to find an equivalent ratio. Again, there is only 1 mark, so you would be expected to do this easily. I took this type of question from a calculator paper, so you could use a calculator if necessary, but hopefully you can do it without a calculator. However, from a process of elimination, we can begin to find the answer. Looking at our original ratio, we can see that the left-hand side digit 4 is smaller than the right-hand side digit 10. Therefore, it can't be these two ratios as the number on the left-hand side of the ratio is larger than the right-hand side. It also can't be this one, as they appear to have divided by 4 on the left-hand side and multiplied by 4 on the right-hand side. So we are left with 2 ratios. If we look at this one, 1 to 2.5, if we look at the left-hand side of the ratio, to get from 4 to 1, we would have to divide through by 4. Therefore, to get the right-hand side, we would have to divide 10 by 4, which is equal to 2.5. And so there's our answer. The ratio of 4 to 10 simplifies to 1 to 2.5. Ratios can also appear in less obvious contexts. For example, look at this question. Rectangle A has a length of 7 centimeters and a width of 5 centimeters. Shape B is a square and has a length of x centimeters. The ratio of the perimeter of rectangle A to the perimeter of square B is 3 to 2. What is the value of x? Notice that there are 3 marks. So this would suggest that the answer needs to have 3 pieces of working out to get to the answer. As we are dealing with ratios of perimeters, let's work out the perimeter of the shape that we already know, rectangle A. So that's 7 add 5 add 7 add 5, or you could have done 2 multiplied by 7 add 2 multiplied by 5, and this gives us the answer 24 centimeters. So that would give you a mark, as we need to work this perimeter out. We now have to work out the perimeter of shape B that satisfies the ratio 3 to 2. This is how I would do it. So let's write down the ratio of 3 to 2, and I'm going to write our new ratio underneath. The left-hand side of the ratio relates to perimeter A, and this is going to be 24. So our new ratio is going to be 24 to something. When we were simplifying, as in the previous 2 questions, we were dividing both sides by the same amount. In this case, looking at the left-hand side of the ratios, to get from 3 to 24, we do the opposite of dividing, which is multiplying. So 3 multiplied by what is equal to 24? You should know your multiplication tables, and the answer of course is 8. 3 8s are 24. I now have to multiply the right-hand side of the ratio by 8, and this will give us 16. So our equivalent ratio of 3 to 2 is 24 to 16. Now remember, 24 relates to the perimeter of the rectangle A. So this 16 will be the perimeter of the square, which is shape B. And so this will be 16 centimeters. You might have worked it out differently, but as long as you get the perimeter of the square being equal to 16 centimeters, it doesn't matter. And so finally, we need to calculate the length of x. We know that the shape is a square, so x must be equal to 16 divided by 4, which is equal to 4 centimeters. And so that's our answer. 1 mark for 4 centimeters. Pause the video and have a go at this question. A shop sells cans of soft drink. On the shelves are cans of cola, lemonade and orangeade in a ratio of 11 to 7 to 4. After selling some cans of cola and lemonade, the ratio is now 7 to 5 to 3. The shop has 24 cans of orangeade. How many cans of soft drink did the shop sell? A key piece of information here is the fact that no one bought any cans of orangeade. We can use this information to work out how many cans of cola and lemonade there were before the sale and after the sale of cans. Let's do the before. So here's the ratio of 11 to 7 to 4. As with the previous question, I'm now going to write an equivalent ratio incorporating what we already know. This is the cola, this is the lemonade, and this is the orangeade. We know that there are 24 cans of orangeade. Again, to write an equivalent ratio, we need to multiply or divide. Focusing on the orangeade, to get from 4 to 24, we have to multiply by 6. Therefore, we now have to multiply through the rest of the ratio by 6. So 11 multiplied by 6 is 66, and 7 multiplied by 6 is 42. Now let's work out how many cans of cola and lemonade there are after some cans are sold. Here's the ratio. And again, we know that there are 24 cans of orangeade. So to get from 3 to 24, we have to multiply through by 8. So to write the equivalent ratio, we have to multiply through by 8. 7 multiplied by 8 is equal to 56. 5 multiplied by 8 is equal to 40. So that's the difficult bit, and there are 2 marks for that. We now have to work out how many cans were sold to get the answer. We can see that 10 cans of cola were sold. That's 66 subtract 56, which is equal to 10. And for the lemonade, that's 42 subtract 40, which is equal to 2. So that's 2 cans of lemonade sold. So in total, 12 cans are sold. And there's our answer. I'm going to look at 2 more questions. Have a go at this one. Orange juice and lemonade are mixed in a ratio of 5 to 7 to make orangeade. Orange juice costs £1.20 per litre and lemonade costs 80p per litre. What is the cost of making 30 litres of orangeade? There are 3 marks for this question. It's slightly different to the previous questions where we could find the answer through writing down equivalent ratios. Let's have a look at the question. The recipe of orangeade is 5 parts orange juice to 7 parts lemonade. That's a total of 12 parts. 5 add 7. So if we bought 5 litres of orange juice and 7 litres of lemonade, we would have 12 litres of orangeade. So how can we use this to help us? Well, let's work out the cost of 12 litres of orangeade. So that's 5 multiplied by £1.20, which is equal to £6, and 7 multiplied by 80p, which is equal to £5.60. So that's a total of £11.60 for 12 litres of orangeade. This would mean, for 24 litres of orangeade, that would be 2 lots of £11.60, which is £23.20. But we need the cost of 6 more litres to get to 30 litres. Well, we know that half of 12 litres is 6 litres, and we've got the cost of 12 litres. So the cost of 6 litres is half the cost of 12 litres, which is £5.80. Therefore, the total cost for 30 litres will be £23.20, add £5.80, which is equal to £29. Working out the cost of 12 litres will give you 1 mark, and then there's 2 marks for working out the cost of 30 litres. You might have worked this out slightly differently, but as long as you get the right answer, that's the key thing. And here's the last question I'm going to cover in this video. So have a look. There are 3 bags, each containing a mixture of red and black balls. In bag 1, 11/25 of the balls are red. In bag 2, 41% of the balls are red. And in bag 3, the ratio of red balls to black balls is 2 to 3. Which bag has the largest proportion of red balls? Show your working. Now this is a non-calculator question, so you need to be able to do this without a calculator. So the numbers in theory should be relatively easy. But it's a classic case of do you know the relationship between fractions, percentages and ratios? Now for me, whenever I see percentages, I'm instantly thinking of that magic number 100. Remember that 41% is 41 out of 100. I'm now going to find percentage equivalents for bag 1 and bag 3. So that means writing fractions out of 100 in each case. So in bag 1, 11/25 are red balls. To find the percentage equivalent, we need to rewrite this fraction as something over 100. Well, you should know that 25 goes into 100 4 times. So we're going to multiply the top and bottom by 4, and this will give us 44 over 100. And of course, that is equal to 44%. Now, of course, we know that bag 2 is 41%, so we don't need to do anything there. And now for bag 3, the ratio of red to black balls is 2 to 3. So the fraction of red balls is 2 over 5. Remember, what this ratio is saying is that for